We're going to begin today to show you how to use the Tormach 77 milling machine to make one of the links for your jack. Now, before you get started, let's just go over a few things very quickly. First off, you're in the machine shop, so you should have your safety glasses on already. Make sure your sleeves are rolled up. You have no jewelry hanging. If you're wearing a hoodie, make sure those hoodie strings are tucked inside, have nothing exposed that can possibly get caught in moving machinery. The emergency stop button will be down like this, and this is what we're going to do. We're going to twist it. There's arrows that show you which direction, and then we're going to push the reset button. After you push the reset button, on the screen you'll notice that the reset button, the soft reset button, the blue button right there is flashing. You're going to also, moving the cursor, you're going to hit that. At this point, the machine needs to be what's called referenced. So before you reference the machine, make sure there is nothing at all blocking it. Nothing is in the vise. There's no tools in the tool holder. So everything is good. Now, to reference the machine, we're going to first reference Z by moving the cursor over to this reference Z box and touching it. The Z axis should move up. It will touch a limit switch, and then the reference Z button will turn green. I'll now do the Y axis. The machine will come closest to us, hit another limit switch, and then it will light green, and then we can do the X reference as well. The A refers to a rotary axis, which is another part of the machine that you can purchase and put on the bed of the milling machine. It allows you to rotate something from 0 to 360 degrees, but we don't have that feature right now, so we just don't have to worry about it at all. Once you've referenced the machine, you'll notice that right now there are absolutely no tools in the machine. So when there are no tools in the machine, it's always a good thing to come over to this little T box down here. That T stands for tool number, and I'm going to put tool number 0 in there. That means there's no tools in there. It's always good to have this box show what's actually in the machine at the time. It's a good habit to do that. Okay, now before we get started on this, we're going to talk about the user interface. Here is Tormach's user interface. It consists of some buttons along the outside, labeled X, Y, Z, and A, and these are the axes that you can choose to move. There is an outer ring here, which rotates left and right, and there is an inner wheel that has a little indentation for your finger to go into it. We'll discuss all of it. There's also a step button. So if you want to use this user interface, we're going to move the axes of the machine. We're going to move the X, the Z, and the Y axes. That happens to be called jogging the machine. Now, the way we're going to do this is very simple. If I want to move the X axis, I will select the X by pushing the X button, and you'll notice that the X button lights up green. That means when I move the X axis, when I move this outer ring, the X axis will move. Also notice that the more I rotate the ring, the faster the axis will move. If I rotate the ring a very small amount, I can get very, very nice, slow, resolved movement in the axes that I want to move. To move the Y-axis, I select the Y-axis, and the Y green light comes on right here. That means I'm going to move the Y-axis. Now, before you move these axes on the CNC machines, it's always a good idea to move it nice and slowly at first. And then once you know you're moving the axis you mean to be moving, you can then move it with a little bit more speed by rotating the ring more. If I select the Z-axis, I can move it down and up. Okay. Down movement is negative, up movement is positive, and we'll discuss the relationship of positive and negative with all the axes moving. Okay, now let's discuss a little bit now this inner ring. Now this inner wheel, I should say, you got the outer ring and the inner wheel. This allows you to move the axes in discrete step sizes. Now the step size is determined by pushing this step button. Now let me just get back to the screen. If you notice up here are the step sizes. Right now, it is on a very tiny step size of just 1/10,000 per step. I can sequentially pushing this step button lets me move to different step sizes. That's 1/1000th of an inch per step. That's 1/100th of an inch per step. And this 0.1/10th of an inch per step is something I personally would never ever use. It's just too big a step size. But let me go over right now to the 0.01 size, and we'll just look at when I rotate this wheel, you can see that the x-axis is moving. Okay, you can see the x-axis is moving. If I select the y-axis, and I can move the y-axis in discrete steps like that. If I increase the step size to the 1/10th of an inch, which I again do not recommend using, you can see how huge, again selecting X, you can see how big the step sizes are in this particular step. Too much. If you're wondering why do you ever want to move the machine in little individual step sizes like this, you just notice sometimes you need to determine the edge of a piece of material, or you need to move very precisely a end mill or a tool into position, and that is when this inner wheel with the little indent in it and it allows you to move it in individual step sizes really comes into use. Okay, let me bring the Z-axis up now. And let me just discuss very quickly the tools and how you put them in and out of the machine. Now right over here on the left, the staff has created a beautiful little tool holder. It has a whole bunch of general purpose tools, spot drills, a regular drill, a nice long 1/2 inch end mill, a nice long 1/4 inch end mill. This is called an edge finder. Edge finder, we will discuss its use later. And this is a 1/8 inch end mill. This is what we will be using to do this particular job that we have to do today. Okay? Now, you'll notice a couple of things. One, all of these tools have different lengths. That's an important thing to recognize. Now, typically when you're doing a milling operation, you'll use multiple tools. You'll use drill bits, you'll use end mills of different diameters and sizes. The job that we're doing today, being the first job that you've ever done on a milling machine, we're going to try to do it very efficiently and make it as simple as possible. So we're only going to use one end mill. If you remember, we've already mapped out our machine strategy. We're going to be taking this 4.5 inch long piece of polyethylene, and we're going to be turning it into a link. Now the link has two holes in it, here and here, and it has a profile. And it turns out that the 1/8 inch end mill that we're going to use is capable of doing both the hole operation and the profiling operation. It does the holes by using circular pockling, and then it does the profile by having us program its profile using, in our case, I believe we use Fusion 360 to generate the G-code. And we'll discuss how to set that up in a second. Now, to that end, it is very important that you understand how to use and put in and out the tools. So let me just go very quickly to discuss how that is done. On the Z-axis, on the left side, there is a button here which is used for doing tool change. Now the tool change operation is done using pneumatics. So when you push that button, you will hear a pneumatic cylinder fire. And what happens basically is a cylinder fires and it opens the collet up in the bottom of the machine. And I can now, with this button pushed in, I can put a tool in place. It's a little tight. When I let go of the button, the tool is locked into position. Okay, to remove the tool, make sure you're holding the tool, push the button, the collet opens, and you can remove the tool and replace it with the next tool you want to use. Now, here's the situation with these CNC milling machines, and this is a part of the milling that will often mess you up, especially when you are a novice to this. As I mentioned before, all of these tools have different lengths. If I set my Z0 for this tool, When I stick this tool in the machine, which is a lot longer, the machine has to know not to bring it down as far as it would plug that one down. So how does the machine account for all these different lengths? It turns out the machine has a tool table inside the software. It's called the tool table, and every tool has two sort of important dimensions: its diameter and its length. And these are called offsets. Now, in a Tormach milling machine, the length offset is the distance between the bottom of this tool. Let me flip it the way it actually will go into the machine. It's the distance from this edge here to the bottom of the tool. So for this 1/8 inch end mill, the offset is this distance here, about 3 inches. Now, if I happen to be using this tool, which is a drill, the offset would be measured from the edge up here to the very bottom of the tool. That would be the offset. Now the diameter of the tool is pretty obvious. This is a 1/2 inch end mill, and its diameter is a 1/2 inch. Now why does the milling machine need to know the diameter of the tool? If I program the milling machine to, let's say, have this tool bore out a 1 inch diameter hole, it needs to know the diameter of the tool so that it can generate a tool path that will leave you with a 1 inch internal diameter hole. So both the diameter and the length offsets are very critical, and they must be entered into the machine. So I want to discuss right now the simplest way to do that. We have here a specialty measuring piece of equipment that is specifically used to measure the offsets of these Tormach tools. Now, this is a very precise granite block, and sitting on top of it is a device that can measure depth. Now, I'm going to make sure that the depth gauge is all the way down on the block, and I'm going to turn it on. I'm going to make sure it reads 0. And now, if you'll notice, in the back of the block here, very conveniently located, is a hole that lets me put the tool holder into the granite block. I can now use this device to measure the offset. So, the offset happens to be 2.9935. I just want to point out that if I'm looking at the little tip that's measured, if you notice the very end of this sticks down a little further than here. So you want to make sure you're taking your measurements in this area. Some students have put the device down over here, and then you'll have an inaccurate measurement. All right, so make sure you're measuring from the tip of this. Just for completeness, I'm going to also measure the offset for this 1/2 inch end mill. So I'm going to do the exact same thing, making sure I measure it accurately, and I'm getting a number 4.168. 4.168. Okay, so here are my offsets. I've written it on a piece of Post-it, and I'm going to now enter it into the milling machine. Okay, to enter this information into the tool table, we're going to hit the offset tab right here. Some of these screens are touch sensitive and some of them are not. So if it's not, you'll just click it with the mouse. And here are the tools. Now these are the tool numbers. Now these numbers have to agree with how you set up the program when you cammed it up. We have chosen tool number 1 to be the 1/8 inch end mill. Here's the description of the tool, here's the diameter, and here's the length. So we have to update everything. So the description I'm going to call a 1/8 end mill. I find that hitting the enter key is the best way to move it over. The tab button doesn't always do what you want it to do. The diameter of a 1/8 inch end mill is 0.125, and its length offset is coming from my Post-it. It's 2.9935. Now I'm going to enter the 1/2 inch end mill as tool number 2. Even though I'm not planning on using this tool, I'm just doing this really for pedagogical purposes. So I'm going to put 1/2 inch end mill. The diameter of a 1/2 inch end mill is 1/2, is 0.5, and its length is 4.168. Okay? Now I'm not using any other tools, so I don't really care about any of these other entries. So I'm just going to go back to the main menu. Okay. Now, at this particular juncture, I've shown you how to move the machine around, which is called jogging, using the ring, the outer ring and the inner wheel. And we know how to select the axes. Let's just talk about turning on the spindles right now. So if I, for example, there's no tools in the machine yet, right? Let's say I were to put tool number 1 into the machine. It is extremely good practice. I would call it an absolute rule that the second you put a tool into the machine, you make sure this tool number here agrees. I also highly recommend that you do not put any tool in the machine whose offset you haven't already put into the tool table. Okay, that's just good practice, and the more you use the machines, I think the more you'll understand why that's a good idea. If I wanted to set this machine at 3,000 RPM, I can just push in the number 3,000 here, and when I hit forward, you'll notice there is a delay. Be very careful not to go near the machine when you hit the forward button, because there is a good delay, I'd say a good 5 seconds. You might think there's something wrong with the machine. You might be tempted to touch the spindle to see why it didn't come on, only to have it come on when you're touching it, which would be disastrous, right? At this point, if you touch that spinning tool, it will cut you so badly, you will obviously regret it. So once these tools are spinning, they are very seriously able to do serious damage. Now, even when they are standing still, let me turn the spindle off right now. Even when these tools are not spinning, they are very sharp, razor sharp. So just rubbing your finger down the edge of that tool can cause a serious cut. Of course, nothing compared to what it would do when it's actually spinning. Okay, now we're kind of basically ready to put our tool, our material, I should say, into the vise, and now set our XY zeros and set our Z zeros. Before we do that, I want to also talk a little bit about the use of this machine and what I think will make life a lot easier for you to understand. To put our stock material in the vise, I'm going to select a set of parallels. The ones I'm selecting are going to allow my piece to stick up a little bit above the vise jaws, which is always a good thing, especially if you need to edge find, which we're not going to have to do, but it's always a good thing. Before you put the parallels in the vise, make absolutely certain the bottom of the vise is clean and free of chips, because remember, any chip that gets under the parallel will result in kicking up everything. So let's open up the vise with the handle. The material we're using is called polyethylene. If you're familiar with anything that has a living hinge, like the box of for example, dental floss, it's all one little plastic box that hinges open. Those things are almost always made out of polyethylene because this material has that property. Anyway, I'm going to stick this in. Now, the rule of thumb for putting something in the vise is you stick it in, you push it down with your hand, you snug it a little bit. Don't tighten it all the way. You snug it a little bit, and then you're going to want to tap it down to get out any little gaps. Now I'm tightening it down strong. Now keep in mind, if you're concerned with the pounding that I just did, damaging the surface of your material, you can put a piece of scrap material on top when you're hitting it with the handle. These edges are going to end up getting cut off anyway. So it's okay in this case to tap it, as long as you kind of are careful just to tap along the edge. Once the piece is down, I'm taking the handle off the vise and I'm putting it back in its place on the side of the machine. Now I am going to describe to you what I think is a good sort of philosophy of how to use the machine. Now I'm going to just move this tool. I'm going to move it kind of close to the bottom left corner. Now I'm just eyeballing this. Let's just see if I am going to want to call that my XY0. Now it's extremely easy to establish X and Y0. All you have to do is go to this X0 button and tap it, and go to the Y0 button and tap it, and you'll notice the X and the Y have become 0. Okay? Now, let me describe to you what I'm talking about in a second. If you've noticed, I just drew the X and Y axes as they would be coming at the origin that we just established. Now, I don't know if you really noticed this, but if you notice, it's the table that's moving in the X and Y directions, and it's not the spindle that's moving in the X to Y directions. So it can get extremely confusing if you think about table movement. So, for example, I'm going to go back to the origin, and by entering the G code in this green box right here, right up here, I'm going to enter G0, which stands for rapid movement, X0, Y0, being careful not to move in the Z direction, and it brings me right back to the origin. Let me come down a little further with the tool. Now, if the world of CNC machining were, let's say, what you would expect it to be, this corner of the piece here would have an X coordinate of about 4.5 and a Y coordinate of about 2 inches. 4.5, 2. Let's see if it's true. I'm going to enter that coordinate right in the green box. I'll do a rapid travel. I'll go to X 4.5 and I'll go to Y 2, and let's see what happens. It went exactly where we expected it to go. So you have to realize something, that the way the coordinate system works is exactly as you would expect it to. However, it's the table that's moving, not the spindle. So in my world, pretend the table is standing still, and it is the spindle that moves. Now that makes life a lot easier for me to think about. If I want to move the tool from here back to there, if it's the spindle that's moving, that would be a negative X direction. So if I go back to my jog dial and I select X, this is the negative direction, and sure enough, it is moving that way. If I want to move the spindle down this way, this should be a Y negative movement. So if I select the Y axis and move it in the negative direction, it goes exactly where I expect it to go. So what I'm basically trying to get everybody who's new to these machines to think about the table standing still and the spindle moving. It will make your life a lot easier. So if I want that spindle to go further this way, it's more negative Y, and it will come that way. If I want the spindle to move this way, that's negative X. I select X and move it in the negative direction. Okay? Now, while we're talking a little bit about G-code, I don't want to spend too much time on it, but we talked about rapid movements. If I enter G0, that's a rapid movement. The machine moves as fast as it can, and it goes back to the origin. If I enter G1 instead of G0, it's not going to move rapidly. It will move as in a feed rate that I specify. So for example, if I want to go back to that X 4.5 and Y2 value, in addition to entering the coordinate, I have to give it what's called a feed rate, which is one with the F word, and a feed rate of 50, which would be inches per minute. Let's see what 50 inches per minute really looks like. You can see it's not moving as fast as it did in rapid. Okay. Now, once I enter G1, it stays in G1, so I could just say X0, Y0, and it will move back at a rate of 15 inches a minute. If you notice down here on the screen, there are these soft sliders, so you can actually increase the feed rate over what you've programmed it for. And you can also change the spindle RPM over or under what you programmed it for. If you hit that button, it goes back to 100%. The reason they let you do that is because when you make a program on one of these CNC machines, when it starts to execute, sometimes you can tell just by the way the chips look, by the sound you hear, you can tell that the feed rate and the RPM are off. And rather than reprogram the entire machine, they let you dial it in here with these sliders. It's very useful. It's like tuning a musical instrument. So just consider that a lot of people do use these sliders to improve the machining process once they program. Okay, now we've discussed the X, Y, and the movement of the table. But what we really haven't discussed yet is how you set Z0. So it turns out that once you've set your tool table offsets properly, you can set your Z with any tool you want that's in the tool table as long as, and this is super important, that number in the corner agrees with the tool that you have in it. The machine does not know what tool you put in it. If I had put tool number 2 in the machine and left this in the one position, it would think tool 1 is in the machine. So be very careful to put the correct tool in. Now, how do I establish Z0? This is one way to do it. Tool number 1 is in the machine right now. So I'm going to move the machine over to a place where I can touch down. So I'm just going to jog it over here. Now, as I said, that sounds a lot like Star Wars. Anyway, we can get there are actually some machining operations that will play a tuning. So there are all kinds of crazy things you can do. Now, I'm going to move the Z-axis down very slowly, but when I get close to the surface, really close, this is a time when I'm going to start using my inner wheel. Okay? I'm going to now start to use my inner wheel to do the touchdown. Now, what should my step size be? I have it in 1,000, so I think it's very nice. This is a good step size to keep it in. Make sure the step size is not too big when you're doing this operation. And again, always do a couple of tests before you do anything rash. So I might actually move the machine up a little just to see what my step sizes look like. They look very good. So now I'm going to just put my piece of paper under here. I'm coming down step by step while wiggling the paper underneath. And when the paper just starts to stick like that, I'm going to call that Z0. Now, how do I establish Z0? Again, I can't emphasize this enough. Make sure that number down there agrees with the tool that's in the machine. Once that's the case, you can just go up to the Z0 button and hit Z0. Now, admittedly, this isn't the most accurate way to do it because that paper does have some thickness, so we are off by probably a couple thousandths of an inch, but for the job we're doing, it's not that critical. If you need to get a Z that's even more accurate, there are other techniques that are more accurate. We can discuss that later. Now, I just want to explain to you how this works. If I now put tool number 2 into the machine, let me do that. Now that tool number 2 is in the machine, it's super important that I change my tool number here to tool number 2. Now let's just check to see if the Z0 for tool number 2 is more or less the same. See, if we did this correctly, then Z0 for tool number 2 should be exactly the same as it is for tool number 1. So I'm just doing this kind of carefully. Again, the paper's stuck. And if you look, the Z is reading 0007, not quite James Bond because that's 000. That's 7/10,000ths of an inch. That's like a fraction of a human hair. So you can see that the Z's will work for both tools as long as your offset table is correct. Once you've received your tools from the staff, before you use any of these tools, it's really important to observe them and look at them for any damage or breakage. There's sometimes, a lot of students use these machines and they don't always report when something goes wrong. So check your end mills, look for chips. If you notice there's any chips, or if you notice that any of these drill bits are dull when you start using them and drilling with them, you might find that they don't drill properly. Tell the lab staff and they'll give you some new replacement tools. We should be pretty much ready to run our job now. So in order to run our job, let's go to, now the program has already been created and it should be in here. So I'm going to go to the File tab. Underneath, let's see, I believe in here should be a folder called Intro to Machining. And in it are called master G codes and the links. And we can make a right link or a left link. Let me see what I have here. Let's make a left link. And I'm just going to say load G code. There you have it. There is our G code on the left, and there is a visual representation of what the part is going to look like on the right. Okay. There are some viewing options. If you go up here to this tab here, if you hit view options, for example, you could look at a top view if you want, and then you would get kind of a better idea of maybe what we're looking at. Okay. Now also notice, let me go back to the G code tab. It's always good to check the G code to make sure our tool numbers are right. And as you can see, it does say tool 01, which is tool number 1, is a 1/8 inch end mill. So let's make sure that we have tool number 1 in the machine and we're ready to go. You will notice that tool number 1 is in the machine right now, and the box down there says tool number 1. Now, the only thing we have to do, we've established our Z, the only thing we have to do is establish the correct XY0. If you notice, the top view shows that the XY0 is located right in the middle of that part. Now we have laser cut out, kind of hard to see this because it is clear. Maybe it'll be a little bit more obvious down here. But we have created some templates that help us get the XY0 correct. So let me just show you how to use that. I can move the table out here, and I'm going to just place this more or less in the middle of my stock material. And I'm going to just come down with my tool. Now there's quite a bit of wiggle room involved in setting my XY0. Again, as I mentioned before, we're trying to make this first job that you have to do kind of as easy as possible. So I'm bringing this down slowly using the ring, and I'm going to move it a little to the left, which is negative X movement, and I'm going to move it a little down in the Y, which is also negative Y movement. And I feel fairly good right now that the tool is centered over my XY0. So now I need to just hit my X0 and my Y0 button. And at this point, I should be able to run the program. Now, before you run one of these programs, I like to think of it as a rocket launch almost, where everyone has to sort of check to make sure everything's been done properly. So the first thing we're going to check is, has the tool offset table been updated for this particular tool? The answer is yes. Have I established my XY0? The answer is yes. Have I established my height, my Z0? The answer is yes. Is that tool number one? Yes, it is. And does it say tool number one here? Yes, it does. Is the program I want to run loaded into the machine? The answer is yes, it is. And with all of those things in place, I'm going to ask myself one last question. During this machining process, is that tool going to hit anything it shouldn't? For example, when it punches through the material, is it going to hit the parallels below? The answer is it should not, because the material is wide enough to accommodate the tool diameter, so it should be clear. Everything looks good, and I'm ready to go. Now, the way these programs work is this. If tool number one is not in that machine, the program will prompt me and ask me to put tool number one into the machine, and then it will go. If tool number one is already in the machine, like it is now, when I hit the cycle start button, it's not going to ask me anything. It's just going to start to go. It's going to assume tool number one is in the machine, and it's going to go. So I'm going to do that. I'm going to hit cycle start. I also want to point out that my hand is going to be right at that emergency stop button. I am ready to hit the e-stop if things don't look good. It's going to start off doing the pocketing operation. We are not using coolant here because this particular material, polypropylene, really doesn't need coolant. Now there may be some chip buildup, so I might attempt to blow away the chips. You can also see the machine is making its progress through the part. We're already at a Z-depth of negative 0.475, which I believe is the final depth. It's now going to pocket out the hole on the right side. Now remember, the machine strategy that we set up for this part was one where we're going to just profile the part right out of the stock material, leaving it in place with what are called tabs. I believe we programmed 3 tabs, so the tabs will not get milled until we get closer to the final depth of the part. So right now, we're just going to get the pure profile, as you can see. Look at the graphic display, it will show you the tool's movement right here. We can go to an ISO view, and you'll see the actual depth of the cut. Okay, let's just see how this came out. Here you see the link, and it's held in with the 3 tabs. And all we have to do now is free it from the stock material by cutting those tabs out, which we'll do on the bandsaw. I'll show you how to do that in a second. Now, before we go to the bandsaw, let me just say that for the most part, the big mistakes that novices make and even sometimes experienced people make, when you're moving the machine, sometimes a few things happen. These are the common things that happen. For example, you think you've selected the x-axis, but in reality you've selected the y-axis. And when you move it, you're expecting it to move left and right, but it moves in and out, and something bad happens because maybe your tool is sitting right here, and when this moves this way, it snaps your tool off. Or you think you're going to move the y-axis because your tool is sitting right here, but in reality, by mistake, you've selected the x-axis and you snapped your tool. Now, one of the ways you can really help yourself out is when you're turning this outer ring, never turn it very much until you're sure you've selected the correct axis and it's moving in the direction you mean it to be moving. So just move it a little bit. A little bit. If you're going in the wrong direction or it's the wrong axis, you'll have time to change. Once you're sure the axis you've selected is correct and the direction you're going in is correct, then you can move this thing with some speed. Okay, so be careful about that. And the other big mistake people make is they just don't update the tool table correctly, or they put the wrong tool in. So if I were to change this to tool number 2, but leave the toolbox at tool number 1, I'd be in big trouble. Okay, we're going to free our link from our stock material by cutting these. There's one tab there, one there, and one there. We're going to free it up. Before we do that, we need to use the bandsaw. There's a little bit of aluminum chips on here, but before I use the bandsaw, let me lower the guard as much as I can. That's good. And there's different ways you can do this. You can look at it yourself and figure out which way you want to do it. I think what I'm going to do is, now keep in mind, once I cut into this material, there's just air there, so be careful. The bandsaw is going to get very easy to use. I think I'm going to cut right there. Go along here, cut that out. I think I'll come out now. Comes out. I think I'll do the same on that side. Okay, I freed my piece, and all I have to do now is stick this in the vise, and I can just use a file to file off these little tabs, and my piece should be finished. Here's where the craftsmanship comes in. I want to get rid of the tab, but doing minimum amount of aesthetic damage. These tabs can be customized, so it's possible that if I were to can this up again, I might make these tabs even smaller because they seem to have held the piece really well. I might take a little sandpaper to get rid of that, but that's pretty good, and I'll just get rid of these other ones.